It's what?
It looks so.
It does look pretty bougie now. Did all of your guys' update yesterday too?
No.
It looked normal yesterday. I taught F period. And then I got up this morning to teach geometry alpha and it was all different. I was like, I don't know what's going on. The cool thing I did notice, this little like laser pointer, you can like circle things or underline things without it leaving a mark, which I think is kind of fun. Cool little trick. All right, so we are starting on p.1. Chapter P is called the prerequisite. So basically it's everything you should know coming into geometry. Also it is, or sorry, not geometry, pre-calc. Also, it's just all over the place. So we're going to be doing something and then off on another thing and then off somewhere else. So just like, it's kind of all over the place. So just kind of be patient with it. And let me know if you're like, I have no idea how we got from here to here. So we're going to start with finding the decimal form for this. So how would I go about finding the decimal for this problem right here?
Putting in your calculator.
Putting in our calculator. We are going to do that, but we are going to do it by hand first, and then we'll do the other two by calculator. Max, what do you think?
Divide it.
Divide it. Good. Which, if I do long division, which one's going to go on the outside? Which one's going to go on the inside?
8
Eight.
on the outer.
Good. And then 7's on the inside. I like to keep track of that negative by just putting it out front. Like we're going to deal with it later. I know if I divide a negative by a positive, I'm going to keep it being negative. Also, I'm not sure why it's such a big number. Okay. So now I'm going to go with long division. It's probably been like a long time since you guys have done long division by hand. So we're just going to review it. That being said, I like to spend time doing this because when you guys get to dividing polynomials, we do the same process. So, okay, so I asked myself, what multiplied by, how many times does 8 go into 7? How many times does 8 go into 7? 0 times. Okay, what about, now we are looking at 7D. How many times does 8 go into 7D? 8, good. 8 times 8 is 64. What do I do now? Subtract them. 70 minus 64 is going to be 6. Now what? Bring down my 0. So now I'm at 60. How many times does 8 go into 60? 7. So I get 56 minus again. I get 4. Bring down another 0. How many times does 8 go into 40? 5. And now we're done. Good. So that is negative 0.875. Now, I love that Crew is like, just put it in the calculator. I don't want to make things harder than they have to be. On this first test, it's an all calculator test. You can use your calculator on whatever you want. So in that case, if this is not a test, I just would throw it in my calculator. So let's do that for the other two. So 13 over 5, how would I do that? And what would I get?
2.6.
2.6. What about 11 over 9? Good, 1.2 repeating. How do I show that? Good. Okay. You guys have retained some math over the summer. You guys know some stuff. We're off to a great start, aren't we? Okay. So again, work harder, not smarter. Unless it says no calculator, or unless I tell you you can't use a calculator on this, don't be afraid to use your calculator. It's your best friend. Okay. Now we're gonna graph on a number line. You guys remember number lines, right? Okay, perfect. I like to do number lines, whatever numbers they tell me are the only numbers I'm going to write on it. There's no need to get crazy outside of that. So I'm just going to put -2 right in the middle. Which symbol is this? Greater than or equal to? Do I want numbers bigger than or smaller than? Bigger. So I want to do open or closed? Closed, and I want to go to the right. Perfect. All right, next one, the two numbers I'm going to put on here on 5 and 6. Open or close on 5. Open or close on 6. Closed. Where am I shading? In between or outside? In between. Perfect. Okay. Now, let's get to number C. Does anyone remember what notation we call this? Interval notation. Very good. Interval notation. Now, interval notation, you guys did a fair amount of this in Algebra 2, right? Okay, I think that over the years we've picked up how much we do it in Algebra 2, so hopefully we don't have to like completely relearn it. I'll just remind you. When I like to review this, I just think about like parentheses, comma, and then I'll just put a bracket, so then we've got one of each symbols, just so we remember what each symbol stands for. The parentheses, does that indicate open or closed? Open, so that means that it is the same thing as a less than or a greater than. That means that bracket represents the opposite, right? Which is closed, and the or equal to's, less than or equal to's or greater than or equal to's. In the same vein, I want to think about the numbers that are listed. The first number is always which number? The smallest number. So I always want the small number first, and I want the big number second. Sometimes with infinity, we want to just kind of throw that around. Remember, it's always smallest number first, biggest number second. Okay, so in this case, when I draw my number line here, can I put infinity on my number line? No, there's not like a spot where infinity goes. It's an idea, it's a concept. So I'll just write 5, and then that negative infinity, it helps me with the direction that I'm going. So am I going to open or close on 5? Open. And which direction am I going to go? To the left. I want everything smaller than 5. All right, have I given you enough tools for you to try the next 3 on your own? Okay, do it.
This one.
What's that?
Shut the door.
Of course. Yeah, I just shut the one close to me, but you can shut that one too. I know it's kind of zoomed far out, but I've got those next 3 on the board if you want to check in on those. Everyone feeling okay with interval notation and number lines? Okay, now we're going to play around with interval notation and inequalities. So an inequality has to have what characteristics? Like, what are some items you need in an inequality?
Did you connect the on B and F, you connect like?
You shade in between them.
Okay.
Yep, good question. I like interval notation because if it just has those 2 numbers, you just want from that to the other one, so just shade them in between.
So you always see like in the middle.
Always shade in the middle.
It's like that.
Now, if I give you a second interval, so like, let's say I said, and we're also gonna do from like 7 to 11, that's when we're gonna shade away from each other. So like this, it would be this set right here, and then if I were to continue down and here's 7 and here's 11, then it would be in between these 2. Close and then open. So it's like this interval and then this interval. Always, always. That's a great question. All right, now that we're gonna get into our inequalities, remember those always have x's and then they have less than, greater than, less than or equal to, greater than or equal to. So they are in like this form down here. So these all count as integrals, or sorry, those all count as inequalities. So we want to take the 3 above and make those look like that. I think that the ones with 2 numbers are the easiest because it's just x in the middle between these 2 numbers. So I've got 5 and I've got 7 and I've got x in the middle. Then I've got some less than and less than or equal to. Whenever you're shading in between, whenever you're connecting those 2 numbers, the first sign is always a less than or equal to, and then the second one is also that exact same sign. They face the same way. Never ever have I given you a problem that looks like this, where the signs are like going opposite directions. Doesn't that just kind of look funny on your paper and in your brain? They need to go the same way. What about the next one? Infinity. Well, let's make that negative infinity. I think it lost the negative in the copy process. Negative infinity to 3. Do I write infinity in my interval notation? No. Less than or equal to, good. So we just say x is less than or equal to 3. I generally like x first. If you write the number first and x second, it doesn't matter, but in this case, it would be like 3 is greater than or equal to x. So I was helping a kid today with their work and they had the right sign, they just had the x in the wrong place, so just make sure, I think it's easier to think about it x first. What numbers do I want? Smaller than 3, so put x first and then it's less than. All right, and then this one is not very well drawn, let's make that a 6, let's make that a 9. And let's make the 6 a closed circle, and then just for sake of practice, let's make the 9 an open circle. It's kind of hard to see, so let's make that 9 an open circle. So then, if I write this in inequality form, what would I write? Less than or equal to? Good, and then, good, and then 9, good. Cool. Okay, you guys are doing awesome. Okay, the next 3 say write as an interval. Do you need me to help you with that, or do you think you can do that on your own? On your own, or we can do the first one together. This first one says x is greater than 6. Do I want numbers bigger than 6 or smaller than 6? Bigger than 6. So what's the smallest number that's okay? Technically 7, but yeah, we'll use 6 just for that interval notation. And we want to go from 6 to infinity. Can I use 6 as my answer? Or does it have to be bigger than 6?
This one election. This is just a reminder or an update that kids are still eating first lunch because it took a while to get through the line. We ask that teachers do not mark them tardy. Students, please be honest and getting back to your classroom ASAP. Do not meander around the hallways. Go back to your classroom if you are not eating lunch. Thank you.
Oh, 10 minutes, right? 12:15. And then with the infinity, what is it always? Not a bracket, parentheses. Always a parentheses. Danny.
Does it matter if you put the 6?
It does because I want the smallest number first, and 6 is smaller than positive infinity. So small number first, and then do you guys know why it's always parentheses with the infinity? Because it could be any number. Remember infinity when I told you, like, can we put it on the number line? You guys were like, no, that's silly, right? If I can't put a dot at infinity, I cannot put a bracket at infinity. So infinity again is like an idea, it's a concept. There's no one number that here I am, I'm at infinity. So we never put a bracket there. It's always a parentheses. All right, you good to do the next 2? All right, take a second, do the next 2. Get those on the board when you are finished. All right, anybody have any questions on those? Yes,
Why is -7 correct?
great question, or equal to. Anything else? All right, awesome. Let's go to the next part. It says rewrite using the distributive property. The distributive property is a property you guys have probably used like without thinking about since the 8th grade. You guys distribute all the time. So when I distribute, in this case, all I'm doing is just multiplying that n to everything inside. I'm just reminding you that we know in algebra, if you have that number on the outside, you cannot just give it to n squared, you also have to give it to that negative q. So if I'm distributing, doing the distributive property, I'm gonna have m times n squared minus m times q. Now, the other one, we're gonna go backwards. So this time I wanna take all the things that I can out of both of those numbers. So what, I guess what's the biggest thing I can take out of both those numbers? Yeah, Joe, good, 3.
3x,
Good, and then 1x, and then how many y's can I take out?
1y.
1y, good. So I can take a 3 out of both of them, so the 3 goes away, and I'm basically left with a 1 in the first term and a 2 in the second term. When I take one X out of both of them, I'm left with an X still in the first term, but no X's in the second one. And then when I take that Y out, I've got no Y's in the first term and then two Y's in the second term. So I've got X minus 2Y squared. Is everybody okay with that? Now, I will tell you, sometimes you guys then look to distribute it back through. That would just put us where we started. So once you've done the factoring, just you're done with that. You did your job. Okay, now we've got some properties. I will tell you on the first test, I will ask you to name properties. So I will, like, the very beginning of the test literally looks like this. I'm like, which property is it? Do we ever do properties again? No, but it's important to know them so you can get at least those handful of points on the first test step, okay? Let's see, if I look at, let me just put it at you guys. Does anybody know any of these already? Yeah, Tegan,
You wanna just go down?
whichever one you already know.
Well, I know A is identity.
Good, A is an identity. I do wanna say it's a multiplicative identity, so I just wanna put a little multiplication in front of it. Why do you know it's the identity?
Because 6 take.
Good. Basically, we're taking a number and we're multiplying it by something and it stays the exact same number. Are there any other identities on here? Does anyone see the other identity? Yeah, Charlie?
Community.
Oh, okay, you wanna give me another one? Okay, give me commutative. Which one's commutative?
I don't know, B or C.
It is B or C. Help us out. Which one is it?
B.
It's B. Good. Remember, commutative is the one where you just switch two things. Everything else stays the same. So in letter B, I'm just switching Y and Z and Y and Z. The X stays outside like it was, so that's why it's commutative. What else we got? We can either do letter C or we can find one that we've already labeled. Yeah, Charlie?
Yes, letter C.
Not distributive. It kind of looks like it. It's associative. How would you like explain associative, Tegan? Like, how do you know that one's associative versus commutative? Because those almost look the same, right?
You're in commutative, you change the order of what's in the parentheses, but you don't change like what is in the parentheses. And then associative, it kind of sounds really confusing, but you do.
You change what's in the parentheses, right? I like to think about associative as like what is being grouped together. So in the first one, it's Y and Z are being grouped together. And then in the second one, it's X and Y are being grouped together. So it's your different, like you're regrouping the things that are together. All right, what about letter D? What's going on in letter D? Additive identity, right? It's another one of our identities. I still am taking a number and I'm adding something to it and I get that same number back. And it's this time it's addition. So we're gonna write that little ADD in the front. Okay, what about letter E? It is a reciprocal. We call it something different here. Inverse, very good. I would say that one third and 3 are reciprocals. The act of this is multiplicative inverse. Whenever you're doing inverse, I can recognize that it's happening because you multiply two things or you add two things together and then you get out the identity. So in multiplication, the identity is 1. So I take two things and multiply them together and I get out 1. What about F? What's going on in F? Not reflect. We would use that more in geometry. I wouldn't call it reflective. What do we call it? We had A times B and then now we have B times A. We flip them. What do we call it when we flip them? We already have this word on the board. Not inverse, commutative. It's another commutative. We're just switching the places.
Nothing special about it.
Nothing special about it. No other words. Basically, what it's commutative property is telling us that it doesn't matter, like the value doesn't change if we multiply A times B or if we do B times A, right? If I said, what's 2 times 3? We all know that's 6, right? Well, if I say what's 3 times 2, you guys still know it's 6. It doesn't change the answer, even though I say them in different orders. All right, what about number or letter G? 7 plus -7 equals 0. It is additive, not an identity though, because remember, identity was the one where we added it to 0 and we got the same letter. What does this one look like? We added 2 numbers together and we got 0. Is it what?
Property of 0?
Ooh, no, not property of 0. I like that idea though. Inverse. This is where we add 2 numbers together and we get out the identity. So because we get the identity of 0, just kind of like the multiplicative inverse, you're multiplying 2 things and you get out 1. We're adding 2 things and we get out 0. So we'll call that additive inverse. And then what's this very last one? Associative. We're regrouping, reassociating. Okay, perfect. You guys are killing it. So I think it's time for lunch. Let's do it. Have an awesome lunch. Please be back by 12:45.